you battling with sandy soil? A lot of Australia does, in particular Perth. What we've got here is a demonstration to show you how one of our products, Coastal Cure, works on improving sandy soils in both holding on to moisture and nutrients and also helping with hydrophobic conditions. So what is Coastal Cure? It's a unique blend of bentonite clay, amorphous silica, and a material called lenodite. Lenodite is essentially ancient compost, and it's very high in carbon and humic acids, and when combined with the other two ingredients, it can create a unique bond that improves sandy soil. So here we've got two jars. They've got a hole in the bottom, and we're going to add some water, and to one of them we're going to add the required amount to replicate what you would do in your garden. So you might want to come here and have a closer look at this. This is what the product looks like. It's very black, and that's the lenodite, but it's also got the amorphous silica and the clay. So I've pre-measured out the equivalent amount of what you would put on a per square meter basis. And so what we're going to do, I'm going to mix this amount into the sand. So you want to be mixing in about 100 to 200 mil into the ground, and it's approximately 1 to 2 kilograms per square meter. I'm then going to add the same amount. You can see these are the same amount of water that I'm going to add to each of them. We're then going to collect what water comes out the bottom and show you the difference. So I'll go ahead and start the experiment. So we've mixed the required amount of Coastal Cure into the jar. You can see it automatically looks a little bit different. You can see the obviously the lenodite, which is very black, has changed the look of the soil. What we're going to do now, so again, we've got a hole in the bottom of each jar. I'm going to pour the same amount of water in each. This may take a while, and we're then going to see what collects in each jar. So this might take a couple of goes. So there's 200 millimeters of water in, or 200 mils, should I say, water in each jar. You can already see how this one has gone to the bottom pretty much straight away. And that's the clay and the amorphous silica and the bentonite changing the sand grains. So you can see how much quicker that is penetrating into the soil than this one. So I've got to put the same. All right, you can see that the ameliorated one has it's virtually drained all the way through. It's still pretty slowly filling up the pore space in here, but yeah, even visually you can see it's significantly different, and I can already see there's a lot more water coming out of this one, and this one is holding up. So we're just going to let that drain out. That one's actually stopped draining. This one's still dripping, so we're just going to leave that for a minute or two, and then we'll do the weigh off. Okay, a couple of minutes gone by. Let's have another look. So again, you can see just the colour alone has changed. They've both pretty much stopped. Well, this one's definitely stopped dripping. This one's still going a little bit, but I think that's good enough for the experiment. So let's show you what's going on. Oh, also you can see on this one, if you come closer, this has still got a zone of where it's still dry and slightly non-wetting. This one here, completely moist and holding all the water. So take them out. You might want to come in here. I don't know if you can see that. Lots of water there, hardly any there. So what we're going to do now, let's just weigh it to see what the difference is. So let's put them back in the glasses. So if we turn that on, it's already tared. So this is the first one. And we've got 6 grams of water, so essentially 6 mils of water. You see that? Tiny bit in there. So now we go to the other one. Tear that. And now we'll pour the other one in. And we've got 46 grams of water. So how's your maths on that one?